Alright, and now we're going to do lesson 58, probability and chance. And I'm really excited about this lesson. I like playing card games. I like throwing things to probability and chance. I feel like that's a fun activity. Also, we play a game in class, random person generator. This has to do with our random person generator. Alright, so what is probability and chance? Probability is how mathematicians use numbers to make sense of certain events happening. So how likely is it that a certain event happens? Well, we assign numbers to it, and then that tells us how likely something is to happen. So if you have a number cube, which is a die, or you have a pair of dice, and you roll them, you win if you roll, say, a 6. That's what you want to roll. So how many 6s are on that number cube? There's only one 6 on that number cube. And so you win, we'll write a 1 to represent you winning. And then how many total chances or total events that might happen, that would be the total number of sides on a number cube. And there are 6 sides on a number cube. And so the chances would be 1, because there's only one 6, to 6, because there's 6 sides. So let's go ahead and write this down and show what it looks like mathematically. Alright, so here's our range of probability. How likely is something to happen? That's basically what probability is. Alright, if you're over here at 1 or 100%, that means something is certain it's going to happen. So the sun rising the next day, we have a 100% chance of that happening. So we are 100% certain that the sun will rise. Now, if you were 50% certain that the sun would rise, that means half of the time the sun rises, half of the time the sun doesn't. That doesn't seem very feasible. So let's think of something where there's a little bit more variability in the chances of something happening. And that would be like what we said earlier, rolling a die. So if you roll the die, what are the chances that you roll an even number? Well, if you think there are, how many even numbers on a die? If you think of a little, not a perfect 1, 2, 3, and then the bottom would be maybe 4, the back would be 5, and this side would be 6. Okay? So if you had a die right here, there would be 6 sides. You got 1, 2, 3, you can see those sides, and the bottom would be 4, the back would be 5, and this side that you can't see on the left-hand side would be 6. Alright, so an even number would be 2, 4, 6. So let's just say you win a prize if you roll an even number. Roll a die. How many even numbers are there? So you are going to write a fraction to determine how likely it is that you're going to roll a even number and get a prize. So let's write this out. So an even number would be on top of the fraction, and then total outcomes would go on the bottom of a fraction. Okay, so let's assign some numbers to these two concepts. So an even number, there's 2, 4, 6. That means there are 3 even numbers, and then the total number of outcomes would be 6, because there are 6 sides to that number cube. So 6 would go on the bottom. Then you could reduce this. So that would reduce to 1/2, or 50%. So you would have a 50% chance of winning the prize, because it would be a 2, a 4, or a 6 that you would need to get. So half the time you would win a prize if you roll that number cube. The other half of the time you would not win a prize. Alright, so the range of probability goes from 0% to 100%. So let's do a couple more. Alright, so I touched on this earlier, but I want to talk about it again. Sample space. And the definition for sample space is all possible outcomes. So if you roll the die, all the possible outcomes that can happen is 1, 2, 3, 4, 5, or 6. You could get one of those numbers, one of those 6 numbers when you roll a die. So sample space is a number that represents everything that could possibly happen. As we said earlier, sample space or possible outcomes goes on the bottom of a fraction. So if you had, what's the possibility that you, probability that you flip a quarter twice? What are all the possible outcomes that you could get when you flip a quarter twice? Or let's say flip 2 quarters. Okay, so your sample space for those 2 quarters, one of them could be heads and the other one could be heads. You could get 2 George Washingtons looking up at you. Or you could flip a head. One quarter lands on heads and the other lands on tails. Or you could get 2 tails. Both quarters lands on tails. Or you could get 1 quarter lands on tails and the other one lands on heads. Okay? So those are all, there's 4 possible outcomes when you flip a quarter twice. Or if you flip 2 quarters. So that would be an example of sample space. So what's the probability that you flip 2 tails? So if you wanted to calculate that, you'd say probability of 2 tails, and that would equal, remember, your sample space, or all possible outcomes. Let's just put all outcomes goes on bottom. And then the likelihood that an event will occur, let's say that you get 2 tails, goes on top. Okay? So 2 tails, how many different scenarios come up with 2 tails? And the answer is 1. 1 scenario. And then how many total outcomes are there? 1, 2, 3, 4. 4 possible outcomes. So you have 1/4, which you guys have memorized, is 25%. Alright? So you have a 25% chance of winning. Okay, let's go ahead and look at this spinner. So if we spin this spinner, and the arrow spins, it's either going to land on C, B, or A. Those are all the possible outcomes. But if you were trying to win a prize, which one would you pick if you wanted to win? I would pick A, because there's a lot more space down here where the spinner would land on A than there are space for B or space for C. So you would pick A. So look at this circle and think about our pie charts that we talked about earlier this year. Now, in a pie chart, a pie represents 100%. Now, if you cut a circle in half, like this line does right here, that means that half of the circle is below and is made up of A, and the other half is made up of B and C. A is the largest sector in this circle. So, let's go ahead and assign for A, the spinner, the arrow is going to point to A about half of the time. Now B and C make up the other half. So we have, and I forgot to tell you, 1/2 equals 50%. Now, so B and C together make up the other half, or the other 50% of the circle. And they are both equal, so they are split in half. So what's half of 50%? That would be, of course, 25%, which is 1/4. Okay, and C is equal to B, so you would land on C about a quarter of the time, or 1/4, or 25%. Notice, all of the sample space should always add up to 100%. 50 plus 25 plus 25 equals 100%. Or 1. 1/2 plus 1/4 plus 1/4 equals 1. Okay, so the question is, if you spun the spinner 28 times, about how many times would the arrow land on A? So, in order to find that out, you would take 28 spins, and you would multiply that by A, which is 1/2. You guys know how to make 28 into a fraction. Put it over 1. 28 times 1 is 28. 1 times 2 is 2. Top divided by bottom. 28 divided by 2 is going to be 14 times. It would land on A about, I'm going to put about 14 times. Now, if you spun the spinner 28 times, about how many times would it land on C? Well, C is 1/4 of the circle, so, or 25% of the circle, so you would land on C about 25% of the time. So you could take 28 times 1/4, 28 can turn into a fraction by putting it over 1. 28 times 1 is 28. 1 times 4 is 4. 28 divided by 4 would be about 7 times. Okay, so that is just on average. On average, you'll land on sector C about 7 times. Okay, so number 2 says a weather forecaster says that there is a 60% chance of rain tomorrow. Find the probability that rain will come. Well, you guys have memorized that 60% is equal to 3/5. So basically that means under these current weather conditions, clouds, barometric pressure, are days exactly like the day that we're having right now. Under these weather conditions, it's going to rain on average about 3 times out of every 5 days, exactly like the day we're having today. So, your probability is going to be 3/5. 3 out of 5 chances that it's going to rain that day. Alright, let's go ahead and talk about some other facets of probability. So we have a bunch of marbles. 5 red, 4 yellow, 2 green, and 1 orange. You draw a marble out, and you win a prize if you pick red. What is the probability? Well, that's what the P stands for. P stands for probability of you drawing a red marble. So, you remember that the event, the number that represents the event happening, goes on top. So how many red marbles are there? 5. Okay? And then the total amount of outcomes goes on bottom. So how many different outcomes could there be? There could be 5 red, 4 yellow, which would be 9, 2 green, which would be 11, and 1 orange, which would be 13. So the total number of outcomes would be 5 plus 4 plus 2 plus 1. So your chances of winning would be 5 out of 13. Okay, now this is a new concept. Complement. Complement is the opposite of the event taking place. So the complement of getting a red would be the probability of not getting a red. And basically what you do for this is you take the probability of it happening. You take 1 and you subtract the probability from it happening from 1. So, in order to do that, you could just take 1 minus 5 over 13. And we know that 1, if we can't take nothing away, or you can't take 5 over 13 away from nothing, so borrow from the 1. So you're basically taking 13 thirteenths and subtracting 5 over 13 from that. So 13 minus 5 is going to be 8 over 13. Alright, so the probability of it not being red is 8 out of 13 times. So there's a greater chance that you lose than you win. But this is still pretty good odds. 5 to 13 is still pretty good odds. Alright, we use playing cards to determine who gets to answer the next question in class. So this is what I call a random person generator. Alright, so what's the probability of me drawing a king? Well, in order to do that, you have to think how many kings, or how many times an event is something happening. Okay, so if I pull a card out, something happened. I pulled a card out. That's an event. So how many kings are in a deck of cards? Well, you got King of Hearts, diamonds, spades, and clubs. Okay, so there will be 4 kings. And in a deck of cards, there's a total of 52 cards. Alright? So what's the probability that I draw a king? Well, it would be 4 out of 52. And if you reduce that, you divide top and bottom by 4. 4 divided by 4 is going to be 1. 52 divided by 4 is going to be 13. Okay? So that your chances of getting a king when you draw them out of a deck of cards would be 1 chance out of every 13 tries. On average, will you pull a king out of that deck of cards? Alright, that's a lesson on probability. Hopefully that makes sense. And I will see you guys tomorrow.